A mysterious world beyond Saturn. In the frigid outer reaches of our solar system, far beyond the warmth of the inner planets, orbits one of Saturn's enigmatic companions, Dione. This small moon, measuring just 695 miles across, smaller than the state of Texas, punches far above its weight in terms of scientific intrigue. While it may appear as just another icy sphere at first glance, Dione boasts a remarkably diverse and complex surface, hinting at a long, dynamic history shaped by ancient impacts, shifting crust, and perhaps even internal activity. Beneath its cracked and cratered shell lies a frozen world where the past is written in ridges, valleys, and bright icy cliffs, each one a fragment of a much larger cosmic narrative waiting to be fully understood. As scientists continue to examine the moon's surface features and possible internal layers, Dione serves as a prime example of how even smaller celestial bodies can contain immense geological and scientific value. Discovery and early observations. For centuries, Dione remained just a faint point of light in the night sky, a tiny celestial object barely distinguishable through the telescopes of early astronomers. It was first observed by Italian astronomer Giovanni Domenico Cassini in 1684, during an era when the outer solar system was largely unknown. At the time, Saturn's family of moons was just beginning to reveal itself to human observers, and the discovery of Dione expanded our understanding of planetary systems. For generations, little more could be gleaned from Earth than its distant glimmer, just another point of light moving through the heavens. But everything changed with the dawn of the space age. In 1980, NASA's Voyager 1 spacecraft swept past Saturn and turned its instruments toward Dione, forever transforming our perception of this icy moon. What it revealed was astonishing. A battered landscape pockmarked by massive impact craters, sweeping bright streaks that defied explanation, and tantalizing signs that Dione's frozen exterior concealed a more active history. The Voyager images marked the beginning of a deeper scientific curiosity, one that would later be reignited and expanded by the Cassini mission decades later. Cassini's far more advanced instruments were able to closely image Dione in unprecedented detail and provided data that would fuel scientific research for years. What was once just a dim speck had now become a compelling world worthy of further exploration, adding a rich layer to Saturn's complex and dynamic moon system. Unraveling the wispy terrain. These streaks, dubbed wispy terrain, puzzled scientists for decades. Were they mysterious surface deposits? Unusual lighting effects? Perhaps remnants of ancient cryovolcanism? The truth remained elusive until the Cassini spacecraft began its close flybys in 2004. With its high-resolution cameras and instruments, Cassini revealed that these enigmatic streaks were, in fact, immense ice cliffs, massive fractures in Dione's crust formed by tectonic forces. These cliffs are not merely small ridges, but dramatic escarpments rising above the surface, glinting with sunlight and stretching across vast distances. Among the most striking examples is Palatine Chasmata, a colossal fracture system that runs for hundreds of miles across the moon's battered terrain. This dramatic canyon is accompanied by other remarkable features such as Padua Chasmata and Carthage Fossae, each etched deep into the moon's icy shell. Together, these structures paint a vivid portrait of Dione's once dynamic interior. They hint at a time when the moon was more geologically active, its crust stretched and cracked by internal stresses, perhaps caused by tidal forces from Saturn or from subsurface shifts. Far from being a static, frozen wasteland, Dione once trembled with motion, its icy skin bearing the scars of a restless, evolving world. The preservation of such features also helps scientists map out tectonic and thermal histories, opening a window into the ancient and possibly ongoing internal mechanics of a moon once dismissed as dormant. Surface clues and inner mysteries. Dione's surface is a contrast of ancient crater-covered plains and younger, smoother regions that hint at resurfacing, evidence that internal processes have shaped this world. The heavily cratered areas are among the oldest surfaces in the solar system, preserving records of early bombardment from the chaotic days of planetary formation. In contrast, the smooth plains suggest more recent geologic activity. With a composition of about 60% ice and 40% rock, scientists believe Dione has a rocky core wrapped in an icy shell. This combination of rock and ice makes Dione dense enough to be interesting, more than just a snowball drifting through space. But there may be more hiding below the surface. Recent gravitational data collected during Cassini's close passes hint at a layered internal structure. Models suggest that beneath its crust lies a potential subsurface ocean, much like those found on Europa, Ganymede, and Enceladus. If confirmed, this would have tremendous implications not only for understanding Dione itself, but also for identifying other small icy worlds that might host similar environments. A possible hidden ocean. One tantalizing clue. Cassini detected a weak interaction between Dione and Saturn's magnetic field, possibly caused by a conductive, salty liquid layer beneath its surface. This has led to the exciting hypothesis that Dione may harbor a global subsurface ocean trapped beneath miles of ice. If so, Dione would join the growing list of ocean worlds, places where water might still exist in liquid form, increasing the chances for life beyond Earth. Scientists are particularly intrigued by the idea that even a faint magnetic field interaction could signal the presence of such an ocean. While Dione lacks the dramatic geysers of Enceladus, a hidden ocean beneath its crust would be a silent, concealed reservoir of secrets, potentially holding the chemical ingredients necessary for life as we know it. Additionally, if such an ocean exists, the interaction between Dione's rocky core and its liquid layer could lead to hydrothermal activity, one of the critical processes that could support microbial life. The presence of such environments beneath an icy exterior would elevate Dione from an object of scientific interest to one of astrobiological significance. Future missions equipped with advanced instruments could investigate this possibility in depth, potentially confirming whether the Moon has, or once had, the conditions necessary for life. Orbital dance and tidal forces. Dione's location and relationships are equally intriguing. It orbits Saturn every 2.7 days, locked in place by tidal forces so that the same face always points toward its planet, a phenomenon known as tidal locking. This synchronous rotation means that Dione's near side always faces Saturn, while its far side forever gazes into the deeper reaches of space. This relationship has led to a stark contrast in surface features between the two hemispheres, with the trailing side displaying more of the wispy terrain, while the leading hemisphere shows heavier cratering. It's also in a gravitational dance with another of Saturn's moons, Enceladus. This 2-to-1 orbital resonance, where Enceladus orbits twice for every single orbit Dione makes, produces tidal heating that likely keeps Enceladus geologically active. Dione experiences less of this heating, but it's enough to raise questions about its internal structure and past activity. These resonant interactions are not just orbital curiosities. They play a vital role in generating the internal heat necessary for subsurface oceans and tectonic activity. Such heating, although subtle, may have prolonged the window during which Dione could have supported internal water flow or even chemical gradients conducive to life. Trojan companions. And Dione doesn't travel alone. Two tiny moons, Helene and Polydeuces, share its orbit, residing at stable gravitational points known as Lagrange points. These Trojan moons are only a few miles across, but their presence adds yet another layer of intrigue to Dione's story. These companions trail and lead Dione in its orbit, acting like celestial sentinels locked in gravitational equilibrium. Their stability and formation also offer insights into the early dynamics of Saturn's moon system and the complex gravitational interplays that govern planetary satellites. Studying these Trojan companions might provide valuable data about how moons capture or co-form smaller bodies, and how those processes affect the evolution of the entire system. While Helene has been observed closely by Cassini, Polydeuces remains relatively less explored, awaiting a future mission to truly reveal its character. Future prospects and unanswered questions. Since the Cassini mission ended in 2017, no spacecraft has returned to Saturn. All that we know about Dione comes from brief encounters, but those short visits have left a lasting impact. Mission concepts have been proposed to revisit this icy moon, possibly exploring the depths beneath its fractured crust. One such concept is a dedicated orbiter that could carry advanced radar instruments to probe beneath the ice, or even a lander to sample surface material directly. There is also the tantalizing possibility of piggybacking Dione-focused instruments on a broader Saturn system mission. By deploying compact, high-resolution imaging tools or spectrometers designed to search for biosignatures, a new generation of spacecraft could begin to answer Dione's lingering questions. Could a subsurface ocean truly exist beneath that frigid crust? Did the Moon once experience widespread cryovolcanism? Could it still harbor conditions favorable to microbial life? The answers lie frozen in the ice, waiting for a mission bold enough to go and find them. The quiet enigma of Dione. For now, Dione remains a frozen relic, whispering secrets across the void. A moon with a split face, half ancient and cratered, half smoothed by time and activity. A place where ice behaves like stone, where fractures stretch for miles, and where the clues to a deeper story lie buried beneath a silent, frozen shell. In the symphony of Saturn's moons, Dione might not be the loudest, but its haunting melody lingers, echoing with questions yet unanswered and mysteries waiting to be unearthed. With every orbit around Saturn, it reminds us that even the most unassuming places can hold the keys to understanding our solar system's dynamic and possibly life-supporting history. The next chapter of Dione's story may well change what we know about habitability in the cold reaches beyond the asteroid belt.